let's take a look at number 4, the distance and height of Kurt Warner's pass is given by the following table. Use the regression capabilities on your graphing calculator to create a quadratic model. So we're looking to use a quadratic regression model. I'm going to start by clearing my calculator. I've done so already. And now I'm going to go to Stat, Edit. I'm going to plug in the following information. Now the height is going to be my y value, the height above ground of the ball, and the distance the ball follows horizontally is going to be my x value. So I'm going to plug in the following values here. And just checking to make sure I've correctly plugged them in. So I've got those in. I'm going to go up to Stats. I'm going to go to Calculate, and it tells me to use the quadratic regression model. Now we've learned in previous problems I can take this and copy it, paste it into y equals by going to vars. Now vars will be found by going here to vars, going down to statistics, going across to EQ, and pressing enter. All right, now let's adjust the window. We want the x values to go from 0, maybe even past 40. So let's go 0 to, let's go up to 60 just to see. And when we know y is the height of the football, we're not going to have negative values. So let's go down here. Let's assume the ball goes above 10, the height above the ball. Let's go out to maybe 50 just to see what we have. Okay, so again, this is going to be the distance. This is Kurt Warner. The ball is passed. This is how far it is above ground. And this is the distance the ball is from Kurt Warner horizontally. So we're going to graph this picture, and then I'm going to go to Windows, and I'm going to set it so this is my 0 to 60 and 0 to 50. Yours might be slightly different. How high in feet did the pass go? How high in feet? So we want to know what is this relative maximum. Second trace, going to maximum, somewhere to the left of this. So I'll just use the arrows and go somewhere to the left, pressing enter, somewhere to the right of the highest point, pressing enter, and back to the highest point. This is the distance horizontally. This is the height above ground. So I'm going to round this to the nearest thousandth. So it would be 41.956 feet above ground. The pass fell incomplete. That means that nobody catches it and eventually hits the ground. How far in yards did it go before hitting the ground? So let's first calculate in feet. Oops, oh, it is in yards. The distance horizontally is already in yards. So we want to know what is this distance. And so I want to know when it hits the ground here by going second, trace, and let's find that 0. We can still see it's above the ground here, so somewhere above, pressing enter, down below, and back to it, guessing. Okay, and this would be scientific notation, which is really equivalent to 0. So this is going to be how far it is in yards from Kurt Warner if it goes incomplete and eventually hits the ground. 55.368 yards. How far did the pass go in feet before hitting the ground? Whoops, my fault here. Let me go back here. The pass felt incomplete. How far did it go in yards before hitting the ground? Perfect. Now we're going to translate this to feet. So we know there's 3 feet in 1 yard. So 55.386 times 3 gives us 166.104 feet. How far did the pass go before Larry Fitzgerald jumped up and caught the ball 10 feet in the air? If I go up to y equals and go down to 10, this is Kurt Warner, the ball is passed. So a common mistake is students assume that Larry caught it at this position. That would be like he caught it like 2 yards after the pass was thrown. Not realistic, but we're going to assume right here it's a longer pass, and we want to know where do these 2 lines intersect. So second trace, intersect, getting closer to that point, and hitting enter, enter, enter. Okay, so again, how far did the pass go? We're talking the horizontal distance, 51.708 yards before Larry caught it 10 feet above ground.